So this is June 2017 paper, unit 1. A seawater containing 27 milligram of sulfate ion per kilogram. So each kilogram, 27 milligram of sulfate ions are there. What is the concentration of sulfate ion in parts per million? So how to get the concentration in ppm? So concentration in ppm, parts per million, is equals to moles of solute or mass of solute divided by mass of the solvent into 1 million. So mass of solute 27, because they should be in the same unit. It is written to 2.7 milligram and per kilogram. Both should be in the same unit. So when we convert the milligram into gram, so we divide by 1000, or I can say 2.7 into 10 power minus 3, that is gram. Divided by per kilogram. So per kilogram means 1000 grams. So this will be 1000, and that is multiplied by 1 billion. So 2.7 exponent minus 3 multiplied by 10 exponent 6 divided by 1 million, divided by 1000. So when we simplify this, we will get the percentage as, like, the concentration as 2.7. So C will be the right answer, because it's like 10 power minus 3. This also 10 power minus 3 when it will come in numerator. So we're left with 2.7. In question 2, how many ions are there in 284 grams of sodium sulfate? So how to find the number of the ions? First, we should get the number of the moles. And remember, this sodium sulfate, it will dissociate into 2 sodium ions and it will dissociate into 1 sulfate ions. So the ratio for molecule to ion is 1:3. Like 1 molecule will give 3 ions. So first we'll find how many moles are there. 248 gram and 142 is a molar mass. So 248 divided by 142. So we'll get 2 moles. And 2 moles, how many particles will be there? 1 mole contains 6 exponent 23. So 2 moles will contain 2 multiplied by 6 into 10 power 23. So it will be 12 into 10 power 23. So these are the moles or molecule. Total number of molecules. So if we have 12 into 10 power 23 molecules, then how many ions will be there? X, because the ratio between molecule to ion is 1:3. So we cross multiply. So 3 multiplied by 12 into 10 power 23. So we'll get 3.6 into 10 power 24, or 36 into 10 power 23. You can also write, but there's no option of 23. That's why 3.6 exponent 24. Is it clear, this question? Then calculate the empirical formula of a compound with the percentage composition is given. So lithium is given, phosphorus is there, and oxygen. 17.9 lithium is there, 26.8 phosphorus is there, and 55.3 is oxygen. So steps, divide by atomic mass, which is for lithium it's 6.9 they mention, for phosphorus 31, and for oxygen it is 16. So 17.9 divided by 6.9 equal 2.59. 26.8 divided by 31 equals 0.86, and 55.3 divided by 16, 3.45. Then divide by smallest value, which is 0.86. So 0.86 we divide. So 2.59 divided by 0.86. This is 3.011. This will be 1. And 3.45 divided by 0.86, which is equals to 4. So formula, when we use a whole number, this will be 3, 1 and 4. So Li should be 3, oxygen, phosphorus should be 1, and oxygen should be 4, Li3PO4. So D will be the right answer. So a lot of questions related to moles. What is the empirical formula of a compound? When 2.6 gram of chromium produce 3.6 gram of chromium oxide. So 2.6 is chromium and 3.8 gram is chromium oxide. It means chromium and oxygen. So we subtract them, 3.8 minus 2.6, so we'll get 1.2. 1.2 is oxygen. So chromium and oxygen, chromium is 2.6 and oxygen is 1.2. Then divide by 52 atomic mass, this divided by 16. So 2.6 divided by 52, that is 0.05. And 1.2 divided by 16, that's equals to 0.075. Then divide by the smallest value, so 0.05. So this will be 1, and 0.075 divided by 0.05, that's equal to 1.5. Whenever one of the values 1.5, 2.5, we'll multiply all of them by 2. So this will turn out to be 2 and 3. So C2 and O3, so that's why C will be the right answer. Then consider the reaction. What is the maximum volume in decimeter cube for sulfur trioxide that could be obtained when 0.5 dm cube of sulfur dioxide is mixed with 1 dm cube of oxygen? So you should first identify the limiting reagent, because using a limiting reagent you can work out the ratio between sulfur dioxide and oxygen is 2:1 according to equation. So if we have 0.5 moles, how many moles of oxygen should be there? X cross multiply. So X should be like 2x, 0.5 divided by 2. So 0.5 divided by 2, 0.25. So this is a volume, because mole ratio and volume ratio is always same. So this is a volume of oxygen needed. But we don't have this 0.25, we have only 1 dm, we have more than what we need. So it means oxygen is an excess reagent and sulfur dioxide is a limiting. So we always find from the limiting reagent, we work out the amount of a product. Excess reagent will give us the wrong product. So the ratio between the reagent and the product is same, 2:2 or 1:1 we can say. So if we have 0.5 dm cube of sulfur dioxide, how much sulfur trioxide will be there? Same as 0.5. So A will be the right answer. Is it clear, this question? So whenever two reagents are given, always find the limiting reagent. Identify an atom which contained unpaired electron in the lowest energy state or a ground state. So beryllium, you have to use a periodic table. Beryllium is 4, carbon is 6, chlorine is 7, and calcium is 20. So when you write the electronic configuration, it will be 1s2, 2s2. For carbon, 1s2, 2s2, 2p2. For chlorine, when we write 1s2, 2s2, 2p6, chlorine is 17, 1s2, 2s2, 2p6, 3s2, 3p5. And for calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So identify the atom with two unpaired electron. When we write, as you can see, when I show the electron in a box model, for carbon, first shell it will have 2 electron. The second shell, the second orbit, it will have 2s, it will have 2, but 2p, because 2p2 means p maximum can have 6, but when 2 electrons are there, so first they will occupy singly. So 2 unpaired electrons are there. And what is the meaning of ground state? It means like it does not lose electron, it's in a normal state. That's why we call it as a ground, or does not gain electron. So B is the right answer, that when we draw for carbon, the carbon is having two unpaired electrons in the orbital. But for other, like here, this is 3p5. So when I draw 3p5, first 1, 2, 3, like singly they will occupy, and then 4 and 5. So there is one unpaired electron, but carbon there are two. Which ion has the largest ionic radius? So you have to check total number of proton, neutron, proton, electron as the number of the shells. Calcium will have 20 protons and it will have 18 electrons. Chlorine will have 17 protons and it will have 18 electrons. All are isoelectronic. Potassium will have 19 protons and it will have 18 electrons. Sulfur will have 16 protons and it will have 18 electrons. So electrons are same, means the shells will be same. Largest ionic radii means weak attraction for the electron. So which one will have a weak attraction? Because here 16 protons are attracting 18 electrons. So this will have the largest ionic radii. If the same question was there, smallest, then calcium will be the right answer, because 20 protons are attracting 18 electrons. So if the number of protons are more than electron, then the size will decrease. If number of electrons are more than proton, the size will increase. The compound with the largest covalent character. Covalent character means like polarization, distortion. So which ion will have a greater distortion? The distortion depends on the size of a positive ion, should be small, and charge on the positive ion should be greater. So in this case, when we see aluminium, aluminium will be +3 and iodine will be larger in size, because the covalent character here refers to polarization. And polarization depends on what? It depends on the size of positive ion. It should be small. Charge on the positive ion should be big, large. And size of the negative ion should be large. So a negative ion which is larger is iodine. So either B can be answered or D. But because aluminium is smaller in size and greater charge +3, so it will cause more distortion to the iodide ion. As a result of greater distortion, it will have a greater covalent character. Then what is the sequence of the orbital from which the electrons are removed in the first for boron? So first we write the electronic configuration. So boron is atomic number 5, so 1s2, 2s2, 2p1. So first 2p will be removed, then 2s will be removed, then 2s will be removed because there are 2 electrons, and then 1s will be removed. Electrons are always removed from the last shell first. And then calcium chloride can be prepared by reaction calcium carbonate. Ionic equation. So ionic equation, we cancel out the common ion in aqueous, so chloride ion will cancel out. So calcium plus 2 hydrogen ion in aqueous gives water and carbon dioxide, and calcium ion should also be there. So it is matching with B. Then an excess of calcium carbonate is used, the sequence of the procedure. So first, if excess is used, first we should filter it off to remove an excess of calcium carbonate, and then we carry out a crystallization. So first filtration should be done and concentrate the solution and slowly evaporate until the crystals will be formed. Then the excess of calcium carbonate was added to 10 cm cube, 2 mole per dm cube. The mass of chloride is 10.4 percentage yield. So practical, using the volume and concentration, first we will find the moles. The excess of calcium carbonate was added to hydrochloric acid. So hydrochloric acid is a limiting reagent. So concentration into volume will give us the moles of hydrochloric acid. Using the moles of hydrochloric acid, we'll find the moles of the salt. The ratio is 2:1. We'll get the moles. Then multiply by molar mass, we'll get the mass in gram. And mass in gram divided by like the practical value divided by theoretical value into 100, we'll get the yield for this reaction, which is about 70.7% will be the yield.